Formally, we shall start the presentation. On behalf of the organizing committee of this international webinar on computing trends in AI, our first expert speaker, I would like to welcome Professor Pao-Ann Hsiung to this program. So let me introduce and read out a brief profile of Professor Pao. Professor Pao-Ann Hsiung, PhD, received his PhD in electrical engineering from the National Taiwan University, Taipei, Taiwan, ROC in 1996. Since August 2007, he has been a full professor at the National Cheng University, Taiwan. Previously, he was the department chair, the Dean of International Affairs at Chung University, and the Director General of Artificial Intelligence Technologies Department at the CIECT government. From August 2015, he was director. He was the director of the Smart Living Technology Research Center, National Chung University. He is currently the director, Research Center on AI and Sustainable Development. Currently, he is also the deputy director of the Taiwan-India Joint Research Center on Artificial Intelligence, National Chung University. He has published more than 300 papers in international journals and conferences. He was the recipient of the 2010 Outstanding Research Award given by the National Chung University. He received the 2001 ACM Taipei chapter Kuo Ting Li Young Researcher for his significant contribution to design automation of electronic systems. He was also a recipient of the 2004 Young Scholar Research Award given by the National Chung University to 5 young faculty members per year. He received several advisor awards for best master thesis, embedded system competitions, and the RFID design competitions. He helped the Chiang City to achieve 2018 Top 7 Smart City in the Intelligence Community Forum, ICF Worldwide Competition. He has also helped obtain huge financial budget in the amount of NT $300 million. Dr. Hsiung is a fellow of the IET, a senior member of the IEEE, a senior member of ACM, and a life member of the IICM. Dr. Hsiung's main research interests include smart system design, deep learning, AIoT, reconfiguration computing, and system design, smart city technology such as smart traffic and smart grid, cognitive radio architectures, system on chip design, embedded real-time system design. So we very much with respect welcome Professor Pao sir to this expert for his expert talk on the topic Trustworthy Artificial Intelligence on today's one-day international webinar. So now I request Professor Pao sir to deliver his expert talk on the topic Trustworthy Artificial Intelligence. Thank you, sir, for accepting our invitation, and extremely sorry for the technical problems created and inconveniences. Thank you, sir. Over to you, Pao sir.
Thank you, Dr. Marjit Singh, for the kind invitation to this excellent webinar on computing trends in AI. As we all know that AI has pervaded all different areas of our human life in the recent years. So I think this webinar is just in time so that we can all investigate on how AI has been or is being applied to all different areas of the life of our life including from the industry perspective as well as the government perspective. But as far as the applications are concerned, we are more focusing on how the technology is being applied and how we are trying to obtain what we want to attain by solving problems in the, like for example, Director Yadav sir just mentioned that the environment pollution and the ecosystem and all these different factors of the society and as well as of the environment should be considered while we are applying technical applications to the society. So that's why I chose this topic, which is called Trustworthy Artificial Intelligence. Basically, we can say it's AI for social good, AI for SG. But before I go into the topic proper, let me briefly introduce myself. Actually, Dr. Marjit Singh already spent a few minutes on my former profile, so I won't go through this slide again. But thank you very much for the invitation. I was the Director General of the Intelligence Department of the local Chai city government back in 2018. We did a lot of things in the city area, like smart street lights, smart commerce, smart hotels, smart traffic, health, education, safety, management. So we had a lot of applications which were directly deployed in the city. We achieved the top 7 Intelligent Communities Award, which was a competition of more than 400 cities in the world. As Dr. Marjit Singh just said, we do have a Taiwan-India Joint Research Center on Artificial Intelligence, which is a joint effort by the Ministry of Science and Technology from Taiwan, and as well as National Chung University and the Indian Institute of Technology, IIT at Ropar. Currently, the research center is located on the campus of IIT Ropar, and from this photo you can see that this was the opening back in 2019, which we held on the campus of IIT Ropar, and we had the director of IIT Ropar as well as our ambassador attending the opening ceremony. We had a lot of events as well as news on the event. At the bottom, you can see that we have the research center. This is the space that was allocated for the research center. So in the future, if any professors or faculty members or students from NERIST would like to cooperate with the Taiwan-India Joint Research Center on Artificial Intelligence, you are most welcome to contact me and we can discuss. Currently, the research center has achieved a lot of things, like we do have collaborative projects. We develop smart systems. We have joint PhD programs. We hold international conferences and webinars, just like this one. We have short courses conducted across the 2 countries. We have academia and industry collaboration. For example, we are currently working with NASSCOM, which is a very big industrial federation in India. We are trying to matchmake the startup companies in India with the industry from Taiwan. We have master programs in data science, and we also have international internship, which are all conducted across not only the 2 universities or institutes, but also across the two nations. So let me go directly to what I would like to talk about today. AI is being deployed, as we all know, in all different areas of the human life. Like, for example, we have AI. Actually, we have a lot of intelligent devices now on ourselves, like the smartphone and the iPad and all. They know more than what we know. So let me give you an example. Once there was a phone call from some unknown number. So normally, because we don't know the number or we don't memorize the phone number, normally we would not know who is calling. But now the smartphone is so smart that the phone does a very deep analysis of whatever contents you have on the phone, through the web, and they tell you that this number might be someone you know who wrote an email before to you. So it is written there. There's a hint that this might be someone, Mr. Something XYZ, something like that. Okay, so I was quite surprised. That is what AI is doing now. AI is being deployed in a lot of areas which we might know, we might not know. But so that's why AI is currently stigmatized for being unethical. That is, whenever we apply AI applications to any areas of the human life, we think about solving problems, and we think about how the problems are being solved, how the problems can make our lives much easier. But the problem is sometimes it itself, the AI itself, has some side effects. Just like we take medicine for our health problems, but the medicine itself could have some side effects. So AI also has its own side effects, which could be drastic if we are not very careful. Yeah. So let's look at a figure here, which from which you can see what exactly is the ethical position of any AI that we talk about. From here you can see. Let me change my pen. Okay. The green one, as we can see, this is what can be done technically. Okay. Suppose the black one is what an organization would like to do. The blue imaginary line is what can be done legally. So as we can see that we do have overlaps between all these different ovals here, but the ethical position could be something like the red one. Okay, so from here we can see that, for example, this part, which belongs to the ethical position of any application that we are talking about, they are legal. They are what an organization would like to do, and they're technically possible. But sometimes there could be some areas of an ethical position which are not currently in the legal area, or there could be some other problems. So this is just an illustrative figure that it might not be true for all applications, but from this we can know that these different areas that we talk about when we are applying any technical application to any real situation, we are always faced with these different kinds of considerations. One is what is technically possible. The other is what is legally allowed. The third is what an organization would like to do, like for example the government or the industry or whatever different organizations we have now, and what is exactly the ethical position for an AI application. So there could be some overlaps here, but there could be something which are not overlapping with any of the ovals. So here we can see that we have to go into the exact ethical position of an application or of a situation before we can talk about what can be done legally, what an organization can do, and what is technically possible. Okay, so that was the introduction. So what exactly is AI for social good? Actually, currently, whenever we talk about social good, we can think about the society, that is the social challenge, the environmental challenge, as well as the public health. So in these three areas, one is sorry, social, the second is environmental, the third is public health. So these are the different challenges that exist today, and we are using AI to solve these problems. But while we are solving these problems, there could be some negative consequences which we have to deal with when we are applying AI to these problems. So this is what we mean by AI for social good. We are using AI for social well-being. For example, we are solving social problems. We are solving environmental pollution problems. We are solving public health problems. But what are the ethical position in all different areas that we are trying to solve the problems, and how we can guarantee that these ethical positions can be maintained when we are applying AI. As we all know, the United Nations has already developed or stated 17 different sustainable development goals. Okay. I wouldn't go into each of the goals. I think most of us know about the goals. What we would rather talk about is how the AI use cases are being applied to the different domains of social good. We have, like, for example, crisis response. So whenever there's a disaster, we do have disaster management techniques, and when we respond to a crisis, sometimes we use AI. Like, so suppose we want to save some human life in some disaster, and it could be a natural disaster. So we have different cases where AI is being applied. The number here, which is given at the bottom of the label, is the number of different AI use cases. This is a survey done by McKinsey Global Institute Analysis. So 17 different use cases of AI in crisis response. So similarly, like, for example, we have for the environment, we have 21 different cases which are being in which we are applying AI to the environment to solve environment problems. We also have like 15 different use cases for infrastructure. So from here, we know that AI is being applied in a lot of different areas of our life, including environment, crisis, society problems, infrastructure, health and hunger, equality and inclusion, education, economic empowerment. Economic empowerment means, like, we are using AI for agriculture. So we are making farmers empowered with more economic capability, so that the agricultural, whoever is doing the agriculture can have more advanced ways of checking the crop growth, the water irrigation issues, etc. Yeah. So with that, we know that AI is being applied for social good in a lot of different areas. But how do these different areas, here we see the areas again, correspond to the Sustainable Development Goals from the United Nations? The Sustainable Development Goals from the United Nations are given here. These are the 17 goals from United Nations. These are called SDGs. And as we can see from the right-hand side, we have the AI use case breakdown. That is, we have the different AI use cases being applied in the different areas as stated by the Sustainable Development Goal. Okay, so like, for example, okay, like this one, we have 29 different AI use cases that are being applied to good health and well-being, which is one of the SDGs. So as we can see, each of the 17 SDGs, they have corresponding AI use cases. Some might be more, some might be less. It depends on the use cases that are being currently applied. What are the bottlenecks for developing AI for social good? Currently, the main problems are divided into 4 different areas. We have critical barriers for most domains, critical barriers for select cases, and we have contextual challenges, potential bottlenecks. As we can see from these different areas, data is one of the major problems here. As we can see, we have data problems here. Data means that one is the availability of data. We know that AI needs a lot of data, what we call as big data. So AI needs big data. At least until now, of course, there is some new trend of going for small AI or AI with small data. We do have this kind of trend going on now, but at least until 1 or 2 years back, we were very much dependent on having a lot of data before the AI models could be trained. And then it depends on how we get an accurate AI model, and then we do the testing and all. But starting at the start of the AI model development, we do need a lot of data. This is one of the barriers here, because not all data are accessible. Like, for example, some of the data could be belonging to some private companies. It could be protected by government laws. There are lots of different problems which might affect the accessibility or the quality of the data. That is also one of the problems. The second problem, as we can see from here, is the AI expertise or the AI practitioner. AI has encountered a rapid development in the past 1 or 2 decades, but the expertise or the human power, the manpower in AI is still very much lacking. We don't have good professionals that are adept in AI technology. We do have a lot of AI courses, lots of engineers who are involved in AI, but it's still not enough. It's still not enough. So this is also one of the problems that currently, while we are developing AI for social good, we are facing this kind of problems. Of course, there are other problems like privacy concerns. So whenever we deal with human beings in any applications or technical applications, we are always concerned with the privacy of an individual or of a group. So these are all different barriers. I won't go into each of the barriers, but we are facing some barriers for developing AI for SG. Okay, so this is about data. So data we could be talking about data, telecommunications data, or we could be talking about satellite data, social media platforms, financial institutions, hospitals, doctors, other health providers. So or the government data. So these data might not be accessible to AI experts or companies that are dealing with AI model training. So this is one of the barrier that we were just now talking about. And then the shortage of the expert AI talent, which I already mentioned just now. Okay, now let's look at what are the different AI techniques or AI capabilities that can be applied for social good. As we can see from the left-hand side, these are all the capabilities, or actually the AI techniques that we are currently using. We do have very mature AI techniques currently. Like, for example, we can have deep learning on structured data. We have natural language processing, NLP. This could be for Chinese, for English, for Arabic, for any language. We have image and video classification. So this is one of the main areas. Actually, another area is object detection and localization. Like, for example, for autonomous driving, object detection and localization is very, very much important. We have language understanding, whenever we deal with robots and all. I think the other professor from Japan who is going to talk about robotics. So in that kind of area, language understanding is very much required. We have sound detection and recognition. We have sentiment analysis. I think one of the companies that is doing very good in sentiment analysis is NEC from Japan. Sentiment analysis use a lot, like, for example, in call center, in all different services where we are always concerned with what is the sentiment, whether the individual is happy, angry, or other feelings. So sentiment analysis is also one of the areas which AI has been working a lot. We have language translation between the different languages, like, for example, between English and French. Face detection, which is a very mature technique now. Like, for example, we have face detection or face recognition, which is being employed in a lot of different areas where individuals need to go through gates or any other kind of entrances. So that is face detection. We have tracking. Tracking is also very much important in AI, because with tracking, we can know which person has gone from which part of the geographical area to other parts. So that's tracking of humans, or we can also do tracking of vehicles. We have emotion recognition, person identification, optical character and handwriting recognition, speech to text, content generation, reinforcement learning, near duplicate or similar detection, etc. So these are all the AI techniques. When we look at which AI technique is being employed or applied to which areas, we can talk about equality and inclusion, education, health and hunger. So we can see from the different colored circles or discs, we can see that some of the techniques are being applied in a lot of areas. Like, for example, deep learning on structured data, NLP, image and video classification, object detection and localization, even language understanding. So there are a lot of different techniques that are being applied in a lot of different areas which are concerned with social good. Like, for example, let me give you one more example. Like, for example, we need okay. Infrastructure. Suppose we talk about the infrastructure, like, for example, buildings or any kinds of infrastructure. We are concerned with object detection and localization. For example, for the safety of the building, or for the safety of the parking area. we talk about the deep learning on structured data, so that we know that which parking space is currently available. So these are all the different ways in which we can apply the techniques. So out of the 18 different AI capabilities that could be used for benefit to benefit society, they can be divided into three different major categories: computer vision, natural language processing, and speech and audio processing. And then we also have three different AI capabilities like reinforcement learning, content generation, structured deep learning, etc. And there's one more thing called analytics techniques. Okay, so these are all AI capabilities that can be applied for social good. But as far as trustworthy AI is concerned, we are often concerned with whenever we are applying these different AI techniques for social good in all the different areas that we just saw. We are concerned with whether the technique, the AI technique, has done what it is supposed to be doing, has not done what it is supposed to be not doing, can automatically or autonomously do what it is supposed to be doing, can we reason or give explanations as to why AI is doing what it is doing, and what is the justice or what is the fairness. Does the AI have any kind of bias or unfair handling or processing of whatever it is supposed to be targeting at? So these are all the different questions that we always put in trustworthy AI. So AI can be applied for social good, that is very good, but is it doing what it is supposed to be doing? That is the first question. The second question is it not doing what it is supposed to be not doing? Okay, like for example, deepfake. Deepfake is something which should not be done, but it could be done, right? So, or some kind of attack, security attack on like for example the image or the video of an autonomous car. Suppose if you attack the video which is being captured by the autonomous car, that is driverless driving car, and suppose you attack it and you make the red signal into green signal, then that is something which it is not supposed to be doing, but it is weak. So it is weak, it is being attacked. So that is something which we should avoid. So this is what we are talking about. We are talking about the non-maleficence. Non-maleficence means that it is not doing what it is not supposed to be doing. And then we talk about the explicability. That is, can we explain why the AI is doing what it is doing? Okay, like for example, if AI tells you to drive right, suppose you are in an autonomous driving car, and AI tells the controller of the car that you should drive right, with what speed, at what angle, etc. So can we explain why this is being decided? I mean, whatever decision the AI is doing, why, for what reason? Even for medical purposes, like when we are talking about tumor detection or tumor segmentation in the lungs or in liver or whatever. So in different organs or tissues in the human body. So whenever we detect malignant tumors, why this is a malignant tumor? Why is this part or this area segmented as malignant tumor? This is what we need explanation for. Without such an explanation, we won't be able to develop basic trust on AI. So this is something which we need to talk about. Autonomy is about how. Let me see, where's my mouse? Okay, autonomy is about how the AI models or the AI system is autonomously doing what it is doing. Is it completely autonomous, or is it half semi-autonomous? That is, the decision is being made by the human or by the operator, or is it completely under the control of the human? So these are all different ways in which a human interacts with an AI model. This is also one of the major trends now on how can a human interact with AI, or we can also state it as a human AI team. Okay, so when human and AI group together as a team, how can they collaborate to achieve what it is supposed to be achieving, like for social good? Then we have justice. Justice is about fairness. We don't want the AI to learn the bias of a human person. We know that all humans have some kind of bias in our minds or in our actions, but we don't want an AI system which is also biased. We can understand that it is biased because the data that we feed the AI model could be biased, unfair. So whatever is in the data, the AI system could just learn from the data that, okay, this is what I should learn because there's bias. I learned the bias. But for a proper handling of the data, whatever is coming inside, like for example the environment data, the pollution data, whatever, we still need to be sure that the handling itself or the processing or the decision that is being made is fair. It does not have any bias, especially bias against the lesser what do you call it, the lesser group, or the team that has a lesser privilege. Okay, so in that case we need to have justice that is being directly embedded into the AI. So these are all the different areas which we can talk about. There are some guidelines for AI for SG collaborations, like we should be sure of the expectations of what is possible with AI. So not everything is possible with AI. There's a misconception that anything can be done with AI. This is a misconception. We should be very clear as to what is expected. There's no simple. There's value in simple solutions. I'm sorry. There's value in simple solutions. It means that if something can be done using a very simple computer program, like for example using if then else or something like that, then or a switch case, then I don't think we need AI. So we should not go for complex solutions when there are simple solutions. Similarly, we have, like for example, all the use cases and the goals should be well defined. We should have deep long-term partnerships to solve large problems successfully. So sometimes it's like this. We apply AI to some specific situation or some specific use case, and we see the result and we think the problem is solved. But this is not for the long term. This is just for that instance or for that particular data set. When we look at it for a long period of time, like for example 5 years, 10 years, we need to go for sustainability. The application, wherever AI is being applied, we have to make sure that whatever solutions, AI solutions that we are proposing for the social problem or for the environment problem or for the economic problem, we need to make sure that the solution itself is sustainable. There are lots of definitions as to what exactly is sustainability, but we can go for the United Nations sustainable definition. There are many different KPIs. I think there are at least 54 different KPIs when we talk about sustainable smart cities, for example. So we can go and look at all the KPIs and we can understand that how our AI solutions can be sustainable, in addition to being trustworthy. So these are all the different guidelines that we can look into when we are developing AI solutions that are trustworthy as well as sustainable. Let me give you some examples. Like one is where AI is being applied for social good. Substance abuse prevention. We know that a lot of youngsters in different countries are being what do you call it? Exposed. Yeah, are being exposed to substance, that is drugs and all, and using AI. Actually, we can find out where exactly is the source of the exposure. Who was the main culprit in exposing youngsters to drugs? That is something which could be done using AI. There are some methods here which we can look at, and this is what is possible with AI. It's not very possible with traditional computer science or other techniques. Okay. The other project which we can talk about when we are talking about AI for social good is the Google project on euphonia. This is a project in which we are trying to make the dysarthric speech That is, some people, they have some problems with their speech, with their vocal cords and all, so they cannot utter or express themselves very clearly. So it's very difficult to understand what they are trying to say. But with large amounts of data, Google has been able to successfully translate whatever these kind of people are saying into normal speech which a normal person can understand. Okay, so this is a very good advancement for social good using AI. Let's look at a small simple video where okay, I don't know how to change it. Let me just hope you can listen to the audio.
So we do not listen the sound.
Pao sir, we cannot hear.
Okay, I'm sorry. I think you cannot hear the audio. Anyway, I can always pass on the video to you later on. Actually, it's available on YouTube. You can look at the video later on. But this is just an example of how AI could be used for social good by helping these kind of people who have diasartic speech, so that it can be transformed into typical speech that other persons can understand. This can help this kind of person provide them with a lot of help. The third example in which AI can be applied for social good is the social media analysis for mental health. By mental health, we mean that people have depressions, all kinds of mental problems, and they suffer a lot. So from social media, we can actually try to find out which are the different people who might be facing these kind of problems. For example, persons who want to commit suicide before before committing suicide, they might go on the social media and say something. So these are all the different ways in which AI could be applied. We could check for keywords, we could check for emotions through language understanding, and then based on these kind of different data, we can target out the individuals or the groups where the depressions or other kinds of mental problems are occurring, and try to help them. So this is also where AI could be applied for social good. This is about using satellite imagery and machine learning to predict poverty. As you can see from here, this is the original satellite images, and then using nighttime maps and other processing, AI processing, we can superimpose these two images and get this one, and based on this, the final set of images, we can see what is the illumination or the density of illumination in any geographical area, and then based on this density, we can predict what will be the poverty or the economic status of that area, and then based on this, the government can provide fundings to the different areas that are facing problems. So this is something which AI could do with satellite imagery by using machine learning to predict poverty. There are other projects for AI for social good. I won't go into details of this, but there are lots of different problems given here. Like, for example, we can check the fake news using reinforcement learning. We can do a communal bird roost tracking. So where the birds are going, how they are moving, what is the effect of the birds on the environment. So, like, for example, we can talk about the diabetic retinopathy, that is the eyes that are being affected by diabetes. This is also a very serious problem for human with diabetes. This prediction can help them and try to cure them or help them at the early stages of the problem, of the health problem. Okay, finally, I would like to talk about a big project that we are currently doing on sustainable smart city, where trustworthy AI is being applied. So this is a national project, and it is supported by the Ministry of Science and Technology of Taiwan. I'm the main project lead. We have some project goals. We are trying to develop sustainable smart city ICCC. ICCC means Integrated Command and Control Center, and we are trying to. I'm sorry about the formatting. We are trying to apply trustworthy AI with respect to law as well as social impacts. We are trying to apply world-class AI technology. We have two different areas, application areas. One is sustainable environment. The other is sustainable traffic. And we are using MLOps, that is the machine learning operations, where AI models are deployed automatically in Docker containers, and the Docker containers are being automatically orchestrated using Kubernetes, Google Kubernetes, and we use kubeflow for the automatic pipeline design, where data can be automatically input, automatically processed, checked for trustworthy AI KPIs, and then applied to wherever it is being applied. So in this whole project, we not only make the whole AI processing, including the data as well as the model automatic, but we also make sure that the data which is coming in is fair. It does not have any imbalance problems, other problems with data, and we also ensure that the model itself is also fair. It is doing what it is supposed to be doing. It is not doing what it is not supposed to be doing. So those are the different criteria for trustworthy AI. And then we are still currently in the first year of the project. So any professor or faculty or faculty members or students of any university or institute in India or outside of India are most welcome to contact me if you want to collaborate in sustainable smart city. We have 2 local cities or counties which will implement our work here, and we are also trying to apply it to some city in India. This is the whole project plan. We have 8 different sub-projects which go by SP1, SP2. We have data governance, we have automatic AI, we have edge AI, we also have image enhancement, like we do deraining and defogging, and then we have smart city law and good governance. We have social justice and sustainable smart cities, and then we have hyperspectral UAV imaging for smart city environment pollution. This is, and I'm sorry, environment monitoring. This is for both air pollution as well as water pollution. And then we have trustworthy smart traffic tracking and management, which does traffic or vehicle tracking across different cameras in a city area. So this is also where we can apply trustworthy AI. Our project has a lot of correspondence to the different SDGs, like we have the SDG on sustainable cities, SDG 11, and then we have equality and justice, SDG 16, etc. So we are trying to use AI models and propose new AI models. We are trying to use sensor and image data and UAV data. So whichever data comes in, we are trying to do data governance here automatically. But actually, we are also trying to do federated learning now because of the data privacy issues. For privacy issues as well as for performance requirements, we are trying to use federated learning in this part. I didn't write it into this slide. And then we have automatic deployment of AI models. We have enhancement of object detection by deraining and defogging. And then these are the two applications we just talked about. Yeah, we have a lot of partners in India, in Taiwan, and other countries. We have 9 different professors from 3 different universities involved in this project. Thank you. Thank you so much for your kind attention, and I'll be happy to take any question if there are. Thank you.
Thank you very much for your very wonderful presentation. You have presented very well regarding this trustworthy artificial intelligence and its applications. I don't have any more technical questions, but except to thank you for accepting our invitation once again. And the thing is that we all look forward to the trustworthy AI only, because AI itself is an artificially created intelligence. So we look forward to trustful AI. There could be problems where such kind of trust is missing somewhere when we implement the AI techniques. So you have presented a very nice and very relevant topic for this webinar, and we are enlightened for this, and hope that in future also such kind of webinars will be organized and you will be helping us. So someone has written, how can we contact you, sir, in the upcoming days, years? This is one question coming from one participant. Can you see in the chat box, sir?
No, I cannot see the chat box. I don't know where it is.
Sir, I am Gautam Sekia. I am Gautam Sekia from Manipur International University. So I have a query that create the presentation from your presentation in PPT through email.
I'm sorry, I didn't get the question. You were saying something about PPT?
Yeah, the PPT. Can we get the presentation through email?
Sure, I'll send it to Dr. Marjit Singh, and then maybe you can get it from Dr. Marjit Singh.
Thank you, sir. Thank you, sir.
Yeah, thank you.
Pao sir, one more question. I can see in the chat box. Sir, can you explain a thing or two about artificial general intelligence? This is one question asked by one of the participants. Can you explain a thing or two about artificial general intelligence?
I'm not very sure what exactly is artificial general intelligence, but I know that artificial intelligence has a lot of different facets where we can talk about artificial intelligence based on like, for example, using different methods: supervised learning, unsupervised learning, reinforcement learning, deep reinforcement learning. There are all different methods where artificial intelligence can be applied. Actually, it depends on the application area. I'm not very sure what exactly is artificial in general intelligence, but it has been applied to all different areas currently.
So if I am permitted, I have a question.
Sure.
If I am permitted, I have a question. I wrote it in the chat box.
Yes, sir. Please carry on, sir.
Yeah, my question I wrote is as it is. Sir, thanks for a comprehensive overview. Thank you very much, Professor. Now, I would like to know, how do you try to ensure data unbiasedness, number one? And what are the parameters of measuring unbiasedness in case of scanty data, less amount of data when we need to go for? How do we ensure that it is not biased? What are the parameters for that?
Okay. Thank you very much for the question. Actually, even fairness or unbiased, there are lots of definitions. If you go and look at there's an open source project called Kserve, or there's also another project called IBM 360. IBM has developed Trustworthy AI with three different packages. One is AIX, Artificial Intelligence Explainability. The other is AIF, Artificial Intelligence Fairness. And the third is ART, Adversarial Robustness Toolbox. These are the three different packages developed by IBM. And out of those three, AIF is the one which is targeting at fairness or unbiased characteristics of data or of the model. As far as fairness is concerned, actually there are 10 different definitions. There are different metrics which can be used for evaluating if data is fair or not. So it depends on the definition that we want to apply for our application. So for each use case or application, we need to first make sure which is the definition of fairness that we want to employ. It could be one of those 10, or maybe another one which we can develop ourselves. Like, for example, if there's a big
Sir, you are muted, sir.
Okay. I didn't know that I was muted, and I talked a lot. Anyway, let me start again. I'm sorry.
Okay.
Thank you very much for the question. Actually, there are three different packages for Trustworthy AI from IBM. It's called IBM 360. In IBM 360, we have AIX, AIF, and ART. AIX is AI explainability. There are lots of different open source programs and ways in which we could explain the data, explain the model. Another package is called AIF, AI fairness. This is what the question is about. Within AI fairness, actually, there are lots of different definitions of fairness. They have 10 different definitions, actually. So if you want to talk about fairness in any kind of data, we have to first to make sure which kind of definition we want to use. Out of those 10, we could apply one of those 10, or you could develop your own metric for AI fairness. So normally for the fairness of data, we use a lot of metrics to make sure that, for example, we have equal amounts of data for each class that we are trying to target at. For example, if you are doing classification, and if we're not doing classification, if we are doing some kind of anomaly detection, then for the different anomaly classes, do we have enough data? Are we biased towards some kind of data or some class of the data? So these are all different metrics which you can use for fairness. You can go and look up AIF, AI fairness, which has these definitions. Actually, there are also source programs in it. And then we have ART, Adversarial Robustness Toolbox, which is also from IBM. They also have a lot of algorithms which can check the weakness or the strength of an AI model, so that we can make sure that the AI model is not being attacked. This is also which I mean we can use, and they are available from IBM 360 for your kind reference. Yeah.
Very much.
So if there are no questions, so let us all thank Professor Pao sir for his wonderful presentation. And we are indeed, sir, very much lucky that you have agreed to our invitation and agreed to address our participants, throw light on the trustworthy artificial intelligence. In fact, this is the future of our humanity. What I believe in me is that. So, and also your connection with India. I remember when we spent together in MET. So it was in 2014. So I still remember those days when we were together there in Noida. So due to this COVID pandemic, no physical meeting could not be happen. So I hope now everything has been, normalcy has started to come. So maybe in our future, we will be able to meet physically. And also our students and the participants from India, they are also very much interested to work with you. And through this forum, I would like to request that if any of our students are interested and if they are qualified enough, so we request that they will be giving some, getting some international exposure through you also. So thank you very much for accepting the invitation and gathering this. This is not the end. This is just beginning for us, sir. And
Sure.
knowledge sharing is a continuing process, and it is never an ending process.
Yeah.
So, and one request to the participants: if you have any other queries and any questions, so you can contact to Pao sir or through our organizers, so that we will forward it to Pao sir, and then he will get back to all of you. So from our side, sir, we thank you very much once again. And from personally from my heart, I thank you very much, sir. Despite your busy schedule, you have agreed to deliver this expert talk. And it was really wonderful. And thank you very much, sir.
Okay. Thank you, Dr. Marjit Singh. It was a pleasure. Thank you so much.
So thank you, sir. And now this session is going to be closed. And we'll begin our next session at 3 p.m. India time. So the next session will be presented by Dr. Yoichi Yamazaki from Japan. So all the participants and interested guests are requested to join our session at 3 p.m. India time. So thank you one and all, and have a nice time. Thank you, Professor Pao sir.
Thank you.
Namaste.
Thank you. Bye-bye. Thank you, Dr. Marjit Singh.
Bye-bye.
Thank you.
Namaste.
Thank you, everyone. Bye-bye.
Thank you.